Dear students, it's me Sindo. Today's topic is Dynamic Force Analysis of Slider Crank Mechanism, Analytical Method Part 2. Today we are going to discuss the dynamic force analysis of slider crank without considering the mass of the connecting rod and crank. And the terms related to the dynamic force analysis are piston effort, thrust on the cylinder walls, thrust along the connecting rod, crank effort, turning moment on the crank, thrust on the bearing. Let us see what these terms are. Okay, so first term is piston effort. Consider a slider crank. Crank is OA and AB is the connecting rod, and this rectangle is a slider. Okay, and an external force F is acting on the slider rightwards. We have already done the static force analysis. What is the difference between static force analysis and dynamic force analysis? In static force analysis, we neglect the mass of the component. We are not considering the inertia force on the different parts. In dynamic force analysis, we are considering the inertia force due to the mass. In this case, we are only considering the mass. We are only considering the mass of the piston. We are neglecting the mass of the connecting rod and crank. And here an external force F is acting. We want to find the turning moment on crank so that the whole system is in dynamic equilibrium. Let's see how this is done. First we want to find the force acting on the piston, then force acting along the connecting rod, and the force acting along the connecting rod into this crank radius, which will apply a torque on the crank, and if we apply an opposite torque on the crank, the whole system will be in the dynamic equilibrium. Okay, so the net piston effort is the net effective force acting on the piston. Piston effort is the net effective force acting on the piston. And how we will find the piston effort? We will use this equation to find the piston effort. We will see what each terms denote in detail. You will have to by heart this equation. Consider a horizontal reciprocating engine. Here what will be the force acting on the piston? The force acting on the piston will be due to the gas pressure, and Fp denotes the force due to the combusted gas pressure, and Fi denotes the inertia force due to the mass of the piston, and Ff is the force due to friction. Okay, so Fp is the force due to gas pressure and Fi is the inertia force. You know, inertia force always act in opposite direction to the acceleration. When the slider is in the left extreme position, that is crank it as 0 degree, and the crank is rotating clockwise direction from 0 to 90 degree, then the slider will move from left extreme position to the mean position. During this movement, the slider is accelerating towards right, and hence the inertia force will be towards left. Hence we will have to use minus sign. That is we will have to subtract the inertia force from the force due to gas pressure. And when the crank is rotating from 90 degree to 180 degree, the slider is decelerating. Hence the inertia force is towards right. So we will have to add the inertia force with the Fp. Hence we have given the sign plus or minus. So general equation is Fp plus or minus Fi, and Ff is always opposing the motion, and we have to subtract the force due to friction always. Okay, and this is the vertical cylinder, and in vertical reciprocating engine, one term is added, that is weight. You will have to add the weight to the force due to gas pressure, that is Fp. And consider a single cylinder double acting engine. Here what is the difference? Here in double acting, the force on the piston is acting in both sides. This side is known as back end side or cover end side, and this end side is known as crank end side. So what will be the net force acting on the piston? Here the net force, general equation is the same for finding the net force, that is Fp plus or minus Fy minus Ff. The Fp is fine using this expression, that is P1A1 minus P2A2, where P1 is the pressure inside the cylinder at cover end side, and P2 is the pressure inside the cylinder at crank end side. So the force is P1A1, and P1A1 acting on right side, and P2A2 towards left side. So whichever is maximum, the force will acting on that side. So the general equation is equal to Fp is equal to P1A1 minus P2A2. So you will have now studied to how to find the piston effort. The piston effort is the net effective force acting on the piston. Now we have to calculate or find the force acting along the connecting rod. So this is the force F, and if we resolve horizontally, we get F is equal to F34 cos beta, and F34 is equal to F by cos beta. So this is the force or thrust acting along the connecting rod. And F14, you have already graphically solved this problem. F14 is the thrust on the side of the cylinder, and F14 you get by resolving vertically. Resolving vertically, you get F14 is equal to F34 sine beta, and F34 already you have find F by cos beta. So writing F34 is equal to F by cos beta, you get F14 is equal to F tan beta. Okay, this is the general equation for finding the thrust on the side of the cylinder. And F34 is equal to F43, and F43 is equal to, but in opposite direction, to F23. And now you will have to find the turning moment. Turning moment is the, the force acting along the connecting rod, and force acting along the connecting rod into perpendicular distance will give you the turning moment. So in order to find the perpendicular distance here, we want to find the angles. Okay, this angle beta and this angle theta, and what will be this angle? This angle will be 180 minus theta plus beta, and what will be this angle? This angle is equal to theta plus beta. So this distance is equal to this is the crank length r, and this distance is equal to r sine theta plus beta. So F34 into r sine theta plus beta will give you the turning moment. So net force applied perpendicular to the crank into perpendicular distance is turning moment, and Ft into r, Ft is equal to force acting along the connecting rod, that is F34 into r sine theta plus beta, and F34 is equal to F by cos beta into r sine theta plus beta, and F into r we take outside, and expanding the sine theta plus beta is equal to sine theta cos beta plus sine beta cos theta divided by cos beta, and dividing the cos beta throughout this, you get fr sine beta plus cos theta sine beta by cos beta. And sine beta expression, we have found the expression for finding sine beta already. Sine beta is equal to sine theta by n, and sine cos beta is equal to 1 by n root of n square minus sine square theta. Substituting this, you get fr sine theta plus 2 sine theta cos theta by 2 into root of n square minus sine square theta, and fr sine theta plus sine 2 theta by root 2 root of n square minus sine square theta. And this is the expression for finding the turning moment. And crank effort. Net force applied perpendicular to the crank is called crank effort. We have already find the Ft. Ft is equal to Fc sine theta plus beta into r. Will give you the turning moment, and the remaining term is the net force applied perpendicular to the crank, that is Fc sine theta plus beta. Expanding, you get F sine theta plus sine 2 theta by 2 root of n square minus sine square theta. And thrust on the bearing. Thrust on the bearing is the parallel component. See, the perpendicular component is the crank effort, and parallel component is the thrust on the bearing. Okay, so thrust on the bearing is equal to Fc. Instead of sine theta, you will give cos theta plus beta, and Fc, substituting for Fc, F by cos beta is equal to cos theta into beta is the net force applied parallel to the crank. This is the thrust on the bearing. So we have studied today piston effort, thrust on the cylinder wall, thrust along the connecting rod, crank effort, turning moment on the crank, and thrust on the bearing. You will have to by heart all the expressions for finding these terms. Thank you. We will see on next class.